Hello and welcome. I was tasked with addressing the productivity and quality challenges that the Lean Sandwich Shop is experiencing. To start, I'd kind of like to just share some basic baseline data. The Sandwich Shop has a current daily demand of 600 sandwiches. They are open 10 hours per day, 364 days per year. With this current demand and availability, the expected annual volume is roughly 218,400 sandwiches. Unfortunately, over the last 12 months, they've experienced a scrap rate of 10%. This has resulted in additional operating costs of roughly $120,000, as you can see here on our cost of quality worksheet. I hope with implementation of a new process to decrease that rate from 10% to 4% in the next 3 months, which should result in an annualized savings of roughly $72,000. When evaluating Lean Sandwich Shop's process, I used several tools to help me identify what was important to the customer, as well as to identify areas of opportunity. Using the voice of the customer matrix, I determined that placing the order and receiving a warm and accurate sandwich was essential. It was determined through the critical quality tree that receiving a sandwich under 10 minutes was also crucial and very important to our customers. This CTQ tree, at this time, the process at Lean Sandwich takes exactly 600 seconds, which is meets that 10-minute mark on the dot. But what exactly does it take, right, to make sure the customer receives a high quality sandwich? Well, looking at our SIPOC diagram, there are 4 major suppliers that provide the shop with the essential inputs to allow for an efficient process. Optimizing Lean's process is critical to obtain the expected outputs and ensure that we do have satisfied customers. When evaluating the potential risks that led to Lean's reorders, it was determined that incorrect veggies, suboptimal quality, and a cold sandwich held the highest priorities, as you can see here in our risk assessment section of our project charter. An opportunity was also highlighted at the wrapping station, the final station prior to the customer receiving their order, where an attribute R&R showed unacceptable miss rates, right? 30%, 6.7%, highlighting the external failure costs noted in the cost of quality worksheet that I presented in previous slides. Here is a high-level value stream map of the current process, showing our suppliers, how often we are receiving daily supplies every 5 days, meat and cheese every 3 days, fish and bread and produce daily. Current process has a lead time of 5 days with a value add of 600 seconds. Here are the details of the current process. At this time, Lean Sandwich Shop operates with 12 employees per day. With an expected takt time of 60 seconds, this yields a TPH of 5 sandwiches per labor hour. I've also highlighted the shop's hourly demand volume. As you can see, that 12 to 1 p.m. timeframe has a demand of 22% of their overall 600 daily demand, which, right, as one can expect, puts a great amount of stress not only on the shop's capacity, but also its process, and kind of stretches that staff a little bit. At this time, as it stands, a little over 50%, roughly 53.8% of the total defect reasons are due to a cold sandwich and or wrong dressing being applied to said sandwich. These defect reasons, coupled with customer wait times, there's a wide variety or variation, my apologies, of wait times. This also leads to frustrations by the customer but also shows areas of opportunity and improvement as well. My proposal for improvement consists of the following, right? Like I had mentioned before, currently Lean Sandwich Shop operates with 12 employees per day. During that 12 to 1 p.m. hour, that bottleneck hour where their demand is 22% of their 600, that would require 22 employees to meet that 132 sandwich demand in that hour. Obviously, we don't have enough staff for that. Process improvement is needed. And based on total process time and tact time, Lean Sandwich Shop should be able to fully support its demand with 10 employees. I propose combining receiving of the order, bread selection, and the addition of protein into one station, which would utilize 2 employees. I also propose removing the physical delivery of completed orders to the customer. This creates unnecessary motion by the employee, a form of waste, delaying the completion of additional orders. By doing this, we can reduce the number of employees wrapping the sandwich and announcing an order to just 1 employee. This is just another work balance table, kind of showing our process cycle times and our utilization by employees. Creating a space for completed orders for those dining in, as well as for those creating curbside pickup, allows the ordering and picking up process to be streamlined and more efficient, decreasing potential bottlenecks. I propose that this will not have a negative effect on sales or customer satisfaction if we clearly indicate the pickup area, as well as the system that will be announcing completed orders if you are dining in. Systems like this are successfully utilized in many other food service locations, quite notably Starbucks and Panera Bread. Here I've provided a standardized work chart as well as proposed work cell to help maintain stability and efficiency at the shop now and in the future. This control chart, while shows the previous TPH of 5, we do not yet have data, right, from the current process that I'm proposing, which should yield a TPH of 6. I just wanted to give you a kind of a starting point and reference. I expect the improvements to increase the overall stability of the process, therefore narrowing the upper and lower control limits from what you see there. Additionally, I've provided a few countermeasures to the initial risk assessment. These countermeasures will greatly decrease the risk of the top defects highlighted in the measure phase. Proposing the employees at the register repeating order back to the customer prior to finalizing to ensure accuracy. Order request moves with the sandwich to each station. Each station employee checks the previous station's work prior to adding additional ingredients. That should greatly reduce the incorrect veggies and toppings that were of concern prior. And then placing refrigerators between the protein and veggie stations. Rotating ingredients based on time removed to maintain quality should help greatly address the ingredients not meeting quality standards. Finally, I'm happy to share the expected annual savings from the process change. Our sandwich productivity improvement, right, with a new TPH of 6, we will decrease our labor hours by roughly 7,300 hours. This will yield savings of around $109,000. And then our scrap reduction improvement, decreasing our DPMO as well as scrap units will yield an additional $110,000 in cost savings. So altogether, with this process improvement change, we will see annual savings of roughly $220,000 overall. This is the end of kind of my proposal. I appreciate this opportunity to present to you, and I hope you consider selecting this implementation process in the future.